Hi guys, welcome to my video, and today we're going to learn about angel relationships. And the first word is vertical angels. That is when the angels go
Okay, good God. That was bad. Aren't you glad he doesn't have to teach the entire lesson, because that would be horrible. He's still sitting over here laughing like it was some sort of like really funny joke. Look at him. Look, what is he doing? He can't even keep himself together. Okay, get out your notes, you guys, because we're going to learn about angle relationships, not angel relationships, because I don't think angels have. I don't know. Okay, we're just going to leave that be. And right now we're going to talk about some vocab. So let's go ahead and figure this out. First one, we've got vertical angles. Okay, so if you need to, first of all, if you need to, pause this video so that you can write everything down and then come back and listen to my description, or you can listen to my description, pause it, write everything, and then go on to the next one. I'm just going to keep going. So if you need more time, pause the video, please. Vertical angles are two angles that are created when two lines intersect, or it's the angles that are created. Actually, there's four angles that are created when two lines intersect. And we know that vertical angles are congruent. So let's talk about this word right here. If you don't know what this word is, in your notes, like do a little arrow thing. Oh, that was not bad. And you need to put this in your notes. Congruent in geometry means equal. It's the same as like equal in algebra. Congruent means equal, but when we're talking about geometry, or when we're in geometry, we're going to use the word congruent. So vertical angles are congruent, which means vertical angles are equal to each other. Okay, here is how we're going to do this. We're going to draw vertical angles here. Let me get out my little, yeah, like that one right there. Okay, so I'm going to draw an angle right there, or sorry, not an angle, a line right there, and I'm going to draw another one right here, and there we go. And I'm going to bring this down so it's a little bit more even. And okay, so that's the picture you can draw. To be actually accurate, what we need to do is we need to put arrows on the ends of this. Okay, that's a little geeky math thing. Sorry, my arrows are a little bit rough. Okay, so what we've created, if we've created four different angles, we've got one right here, we've got an angle right here, we've got an angle right here, we've got an angle right here. In the center, okay, we've got the intersecting point. Okay, so vertical angles are these ones, are the ones that are across from each other. Okay, and we know that those are the same. So this one, that's how you mark an angle right there, with a little half circle. And this one are going to be vertical angles. Those are going to be the same. So if this one is 80 degrees over here, this one over here is also 80 degrees. Okay, and then you also have another set of vertical angles, which would be this one right here. And in order to show this one, we're going to show this with two half circles, or two half circles there would be good. Okay, so this one and this one are the exact same. Okay, really important for you to know. Okay, pause that if you need to. We're moving on. Adjacent angles. Adjacent angles are two angles that are right next to each other, and they share the same vertex, or the same point, and they share a side. So here we go. We're going to start this up again, and we're going to create some angles right here. I don't even know what that is. Curved. No, we're going to do this. We're just going to go create an angle here. Let's do that one right there. Okay. Okay. There's one right there. And there's one right there. Okay, I'm going to move this and show you, okay, what we've got here. Okay. I'm going to put angles here, or sorry, arrows here. And what I've done is I've created two angles. Okay. I've got this angle right here. Okay. And so we'll call this angle A, and this one is angle B right here. And the reason these are adjacent is because they share a side. So here's the side that they share. They share this side right there. And then they also share their vertex. The vertex is the corner, or it's the intersecting point, and they share that. This point right here is on angle A, and it's also angle B. Okay, so those are adjacent angles. Okay, two angles that are right next to each other. Okay, just for a little side note, if you want to write this down, go ahead and do this, because we will use this when we talk about supplementary angles. But when we have a straight line, okay, in a straight line, whoa, I don't even know what just happened. It's awesome. In a straight line, okay, there is 180 degrees, because that's half of a circle. Circle is 360, so a straight line is half of a circle, which is going to be 180 degrees. So if I wanted to write like an equation, A plus B, that's going to equal 180 degrees, because they form a straight line. Okay, little side note. All right, next we've got complementary angles. Notice this is not an I, it's complementary, not complementary. Okay, complementary would be like, hey, nice angles. Okay, that was bad. Okay, complementary angles are two angles with a sum, meaning they add, okay, up to 90. Okay, so any two angles that have a sum of 90 degrees. So if I wanted to draw a 90-degree angle, let's just say we'll go back to our tools here, and I'm going to draw 90-degree angle. There's one there, and here's a 90-degree angle right there. Perfect. Okay, that's a 90-degree angle. We often signify or denote a 90-degree angle with a box in the corner. Okay, that's a 90-degree angle. So two angles that add up to be 90 degrees are called complementary. So that would be if I threw in an angle, let's say we do something like this. If I threw in an angle, let's make it down here like this. That right there is going to create complementary angles, because I know that this angle right here and this angle, we'll call this one 1 and this angle 2. We know that they combine to make this entire angle, which is 90 degrees, because of the box in the corner. So I know that angle 1 plus angle 2 is equal to 90. They are complementary angles. They add to 90. Okay. Supplementary angles are two angles with a sum of 180 degrees, or what we call a straight line. I'm going to write this in here. This is a straight, sorry, my handwriting is horrible on this. 180 degrees is a straight line. So all I have to do here is draw myself a straight line. It'll look something like this, like that. Put some arrows on the ends, call it good, and that right there creates supplementary angles. Supplementary angles, angle 1 and angle 2. I know those combine to form a straight line. Therefore, I know angle 1 plus angle 2 is equal to 180 degrees, because they form this straight line right here. Okay. Let me think. Is there anything else with this? I don't know. How's your day going? Okay. Great. Excellent. We're going to move on. Actually, I think that's the end of this video. We're going to do this in two parts, just because I don't want to make this one super long. So that's the end of our notes. Let me take a quick look to make sure. Yep, we're going to do this. Oh, well, you know what? We're going to go ahead and do this in this video right now. So let's go ahead and identify. I'm going to use these colors right here. So we're going to identify some vertical angles here. So vertical angles, two angles, opposite angles that are formed when two lines intersect. So I'm going to take this line, line BE, and line DA right here, and they intersect right here at this point. And I know that this angle right here and this angle right here are going to be opposite each other. So those are vertical angles. There are some other vertical angles in here. Those are the two that I decided to use. We've got some adjacent angles. Okay, adjacent angles are two angles that are right next to each other that share a vertex. And I'm going to say that this is going to be the vertex. And I'm going to say that this right here is the line that they're going to share. And I'm going to use this angle, this 50-degree angle, and this angle right here. Those are right next to each other. They share this line and they share that vertex. Those would be adjacent angles. Okay. Let's use complementary angles. Okay. So complementary angles, this is a little bit tougher one to show here. I'm going to erase this. Okay. Two angles that form 90. So you're going to have to stick with me on this one. Okay. I know that this right here is 90 degrees. Okay. And it forms a straight line right here. Sorry, that's not all that straight. That's a straight line, right? Ooh, nice little tail at the end. So if this is 90 and the straight line forms 180, then I also know that this one right here has to be 90 as well, because 90 plus 90 is 180, and that would be my straight line. So what that tells me is that two angles that make 90 degrees would be this one combined with this one is going to equal 90, because this one plus this one equals the 90. And then this one is also 90, and that makes my full 180. Okay. Last but not least, we've got supplementary angles. Supplementary angles are two angles with a sum of 180. So all you're looking for here with a sum of 180 is a straight line. And I'm going to choose this as my straight line. We're going to choose BE as my straight line. Right there. And I'm going to take two angles that add up to be this. So I'm going to take this first one, that big angle right there, angle B, F, D. That's how you say that. You name it by the end point here, the vertex F, and the other end point. Okay. So the way I would write that is I would write angle B, F, D. Okay, and that combined with this angle is going to form, and this forms that 180. So that's not the only 180 line. That's also not the only supplementary angles. I would name this angle D, F, E. Important for you guys to understand how we name angles. Okay, so you start with D, F, E, that's this angle right there. Okay. All right. That really does finish off my video. And we're going to do this next. So I'm out of here. I'm going to start a new video right now. See ya. I don't know why I did that. That was weird. All right, guys, here we go. We're going to start up with the angle relationships problems. Now we're going to use those relationships that we just talked about in the first video, and now we're going to set up some problems and try and solve. To help you solve this one, I've got a guest today. Yes, that's right, a guest, and it is going to be the cool son. Okay, not Eli. I know that's what you guys were all thinking. It's actually Karsten here. Karsten, why don't you set up this problem and help him figure out how to do it? Get off your phone.
The answer is 12.
You just gave him the answer, dude. How would you do the problem?
X is 12.
Okay, so that blew up in my face, and that's what you have to look forward to when you get to high school. Here is how we do this problem. You're going to have to leave. Seriously, get out of here. Okay. He is right. The answer is 12, but I'm going to show you how to do that, all right? So here's what we need to figure out. We know that these two angles, this angle right here and this angle right here, add up to be 90 because of this little box in the corner. So what that tells me is I can set up an equation here, okay? And this is an equation that you're now going to be able to solve using all of that really cool stuff that you guys already know how to do. So here is how you would set up this problem. Pardon my handwriting because it's with the finger on the screen. It's messy. Okay. I know that 35. Oh, if you're not writing this down, pause the video, write down this example right here, okay, so that you can have this in your notes. Plus 4x plus 7, okay, is equal to 90. And I know that because of this, what it tells me right here. It says that this angle plus this angle is equal to 90. And now you have to solve. Well, the good news is we know how to solve because you were taught well, not by me, by somebody else, okay? We're going to solve. We're going to combine like terms here. That's going to give me an answer of 42 plus 4x is equal to 90. And now what you have to do is you have to, there we go. We've got to subtract and get the x all by itself. So you should be good right now. We're going to start furthest away from that x, and I'm going to get rid of that 42, and that's going to be here. The reason I subtract is because that's a positive 42x, and we have to do the opposite. 4x is equal to 40. Let's see, 90 minus 42 is going to be 48, which means x is going to equal, it should equal, if I divide both sides by 4, that should equal 12 right here. So, as Karsten said before, in a very excited way, x is equal to 12 here, okay? But then they also say, find the measure of y, x, and it should say, find the measure of angle, y, x, z. So that's this angle, y, x, z is that angle right there. So I got to find out what that measurement is. Well, that's easy because I know that that right there is 4 times x plus 7. So 4 times x, which we said was 12, right? Because it says it right there, plus 7. That looks like it's going to be 55 because 4 times 12 is 48 plus 7 is 55. But guess what? You already knew that it was 55. So we could have actually, I'm going to show you a different way of doing this. You already knew it was, I don't know why I'm whispering. Wait. Okay. 4x plus 7 is equal to 55. You know that because 55 right here, this would be 55 right here. Ooh, that's right with the computer. 55 plus 35 equals 90, which we knew it was. So all you have to do is subtract 35 from 90, and you knew that this was going to be 55, and you could have written that answer in right away. And then you could have written a different equation, and that equation would have been something like 4x plus 7 is equal to 55. Solve that, and you would have got x is equal to 12. That could have been an easier way. Okay, both ways, 100% work. All right, here we go. I'm going to erase this up here and get this out of the way for you. Here's my next problem. Okay, first of all, whenever you're trying to do this, identify the relationship between the angles. I know that these angles, we've got this angle right here, and I'll call this angle JML. This angle plus this angle right here, which we'll call LMN. I know that those form a straight line, and I know that a straight line is 180. So my equation is if I could take 3x, that angle, if I add 54, I know that that's going to equal 180. But I already know what this angle is, right? I know what this angle is because if both of them add up to be 180 and this one right here is 54, well, then I just take 180 minus 54, and that's going to be 126. So I know that this angle is going to be 126 plus 54. That's going to give me my 180. And now you could use this to solve. My equation here would be 3x is equal to 126. You're going to see that right now because I'm going to solve this equation, right? By the way, angle LMN. I know that that angle is going to be 126 degrees. That is what we just found out here. I'm going to show you, and we're going to do this by solving an equation because we're going to use mathy stuff, as my friend Brian Crawford would say. I'm going to subtract 54 to both sides. Guyver, make sure you show him that. I gave him some props in my video, and this is going to be 126. And by the way, I just said that at 126 right there. Okay, divide both sides by 3. Divide this by 3, and x is equal to, I don't know what this is, and it may be 42. Should we say, let's just say 42. Okay, you might have to do some extra math. Put 126 in the box, divide it by 3, call it good. But my answer is 42. So that's what x is equal to. When you plug that in, you get 126, add 54, I get 180, and that is it. All right, last but not least, I'm going to get rid of these. Okay, we have to find y in this situation. I've got 2 lines that are crossing, okay, and I also want to find the measure of ABC. Oh, you know what? I didn't even put these on there. Let me go ahead and put a little dot right there, and we're going to call that A. We're going to call the center point right here, we'll call that B, and I'll put a point out here. We'll call that C. There we go. I want to find the measure of A, B, C. Well, first thing is find the relationship. These are vertical angles because they cross, okay? Not like Eli said, vertical angels. No, it's vertical angles, okay? And I know that vertical angles, if you look in your notes, they are congruent. So this is 80, which means this one over here has to be, yes, this is angle ABC, and it has to be 80 degrees, okay? Because they're the same. Congruent means the same. So the other thing is find out what y is equal to. Well, I know that this angle has to be 80, so that means that 4y has to equal 80. And all we got to do is solve. Draw the fence and solve by doing the opposite. That says multiply by 4, so we're going to divide by 4. And you guessed it, y is going to equal 80 divided by 4 is 20, and y is equal to 20. And I've got both of my answers done and ready to go. Y is equal, y is equal to 20 right there, okay? These are the types of problems that you're going to have to do tonight for homework. That's both parts. Let me make sure. Yep, I got nothing else for you. I hope you enjoyed my guests for today. I will make sure I punish them for their display, at least Karsten, because that was, fairly ridiculous. But enjoy. Let me know if you have any questions. See ya. All right, guys, this is a pretty easy lesson right here. We are going to be talking about similar figures and similar figures. We're going to start with this explore activity that you guys are going to see. Let's see, it's on page 329. If you guys want to follow along with me, that's awesome. Pause it and get to that spot. What I'm going to do is I'm going to help you read what is going on right here, and then we're going to translate it over here to this figure and see what's happening. Okay, so let's go ahead and get started. What it says is when creating an animation, figures need to be translated, reflected, rotated, and sometimes dilated. As an example, apply the indicated sequence of transformations. A sequence of transformations means we're just going to have a combination of transformations. We're going to translate it, we're going to reflect it, we're going to rotate it, we're going to dilate it, that sort of thing. Okay. Label each image with the letter of the transformation applied. So this first one is going to be A, then the next one's going to be B, and we're going to keep going from the previous one. Okay, so what this says is we're going to add 7 to X, and then we're going to take away 2. Whoa. We're going to take away 2 from Y. Okay, it keeps doing that. I'm not sure why it's doing that. All right, so all we have to do is I'm going to take this shape right here and I'm going to translate it, okay? 7 to the right and 2 units down, okay? Because adding 7 to every x means you're just going to add 7 to the x, and then 2, taking away 2 from y means we're going to move it down 2. So I'm just going to start with this point. We're going to go 1, 2, 3, 4, 5, 6, 7, and down 2. And that point is going to be right there. Now, from there, this point right here went to here. So all we're doing is we're sliding it. So I know that this point is just 2 above here. So I'm just going to go 2 above there. And then I know that all these ones are 1, 2, 3, 4 over here. So 1, 2, 3, 4. That's going to be this one. And this one's going to be right here. Okay. So I'm not going to draw that, but I will say, oh my gosh, this is starting to make me upset now. Okay, I will say that this is A. Okay, I'm going to use a different color now, and we're going to tackle B, right? I could draw that shape, but I think you guys can probably see that all right. I don't want to waste any time, okay? What this is going to say is now, okay, keep the X the same, but take all the Y values and make them opposite. Okay, and what that's going to do is all these X values that are right here are going to stay the same. So this is X1. All of these ones stay as X1, but this Y value, instead of it being 1, 2, 3, positive 4, it's now going to change to be negative 4, which means this point is going to stay X1, but the Y value is going to go 1, 2, 3, 4. That to me looks like we are reflecting it across the x-axis right here. So that's what we're going to do. We're going to reflect this, and it's going to come like here. And then these ones over here, we're going to go 1, 2, 3, 4, 1, 2, 3, and 4. We're going to reflect that there, and this one right here. And that, this shape right here is folded over to become this shape right there, and that is B. All right, we're going to change to a different color now. We're going to go with C, and it says rotate 90 degrees clockwise around the origin. So that means we're going to take this and we're going to spin it to be over here. This is where you would probably use your deli paper if you have it. And I'm going to do it like this. We're 1, 2, 3. Sorry, 1, 2, 3, 4. 1, 2, 3, 4. Down 1. That point right there is going to be this point right there. It's going to rotate and go here. So this point right here is going to be this one. Okay. And these 2 points are just going to be 4 spots down, because remember, if this line is horizontal, when we rotate it 90 degrees, it's now going to be vertical. So it's going to be right here and right here. All right. And that we are going to call C. All we did was spin that. Hopefully we're seeing that. We're going to change colors again, and we're going to go with D. And D tells me, oh, it looks like this one again, so that means it's going to be a translation. We're going to add 5 to the X's, and we're going to add 3 to the Y's, okay? So we're going to add 5 to the X's. So that means adding 5 means we're going to move right 5 and up 3. So I'm going to go from this point right here, and we're going to go 1, 2, 3, 4, 5, and up 3, 2, 3. That point right there is going to end up right here. Now I can go off of all my other points, because this point right here is just going to be 2 to the left of it. So I know it's going to be right here. And the other ones are going to be just 4 below it. Right there and right there. Now, if you wanted to check, this point ends up here, which means it should have gone 5 to the right. 1, 2, 3, 4, 5, and up 3. 1, 2, 3. There it is. All right, so that is going to be D. Looks like a B, sorry. It's D. Next, we are going to do E. And I think this is going to be the last one. Now, what this one says is take all my x values and multiply them by 3, and all the y values and multiply them by 3. So I'm going to take this one right here, okay? And this is 1, 2, right? So I'll write that over here. It's 1, 2. Well, if I take all of that and I multiply it by 3, this is going to be 3, 6 now. So this point is now going to get blown up to be 1, 2, 3, 1, 2, 3, 4, 5, and 6. It's going to be way up here. This one is -1, 2. So we'll write that down here, -1, 2. So that's now going to be -3, 6. So it's going to be 1, 2, 3, 1, 2, 3, 4, 5, and 6. Right there. And you can see, here's my line right there. Okay. It now is 1, 2, 3, 4, 5, 6. That distance was 2, and now it's 6. You'll notice that it multiplied by 3. So that means all of my distances have been multiplied by 3. So what we can do, instead of doing the point thing, we can go 1, 2, 3, 4. So that distance was 4. So now it's going to be 3 times that, which is going to be 12. So I can go from here and I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. It's going to be way down here. And then this one is going to be over here. And you can see that we can draw that line there. Sorry, it's really tough to draw these lines with your finger. Oh, that one's not bad. And this one right here. There is my last one, and we'll call this one E. Okay, list the coordinates of the vertices of E. We can do that. We already did. We've got my coordinates of E are going to be, we'll start with this one way up here, and that is 3, 6. Then below that, right down here in this corner, that's 3, -6. And then we've got this one in this corner, that's -3, -6. And the last one, I can't fit it on there. It's this top corner up here, and that's going to be -3, +6. All right, compare the following attributes of rectangle E, that's the orange one, to those of the original figure. The original figure was this one up here. So the shape, let's see, we'll go here. The shape is going to be the same. They're both rectangles. Whoa, sorry about that. The size, we're going to write rectangle E is 3 times bigger. And the angle measures, well, the angle measures are all going to be the same as well. They were all 90 degrees. Okay. All right, we're done. All right, let's figure out what all this means. All this means is this right here. Write this down, pause it if you need to. I'll give you a minute. Here's what we know about similar figures. Notice, we've already talked about congruent figures. Congruent figures mean they're equal, right? It's geometry's way of saying equal. Now we're talking about similar figures. Similar figures, 3 things in common. First of all, we already know they have the same shape. Like the ones we just did, they were rectangles. They also have the same angle measures. The one we just did had right angles. Didn't matter what we did, we stayed with right angles. But the side lengths are going to be different. And we're going to use this word here. And this is the word that I want you guys to pay attention to. Sorry, it keeps doing that. I don't like that at all. Proportional. Okay, that just means that all the sides have been multiplied by something. In the case of the one that we just did, they all got multiplied by 3. That was what we would call my scale factor in my dilation. Okay, hopefully remember that. Okay, write that down. Important for you to know. And last but not least, 2 figures are said to be similar if you can go from one to the other by using a series of translations, reflections, rotations, and dilations. So you know that one is similar to the other one if you can figure out that all we did was translate this and then reflected it and then rotated it and then dilated it. If you know that we can get from one to the other by using any one of those four, then you know that the figures are going to be similar. That's what you're going to work on today in your homework. All right. We'll see you later. Hope you guys are doing well. Let me know if you have any questions. Shoot me a call. All right. All right, here we go. We are talking about the reciprocal function family. And this is actually my second video because I messed up on the first one. So hopefully I can get this one right. We are talking about the reciprocal function family. The reason they call it reciprocal functions is because they threw that X on the bottom, the reciprocal, as sometimes I will say. That's a simplified version of that, but they threw the X on the bottom. So it looks like a reciprocal, or it is a reciprocal. Just like any function that we have, we can change these functions. We can transform them. We can compress them. We can stretch them out. We can reflect them horizontally or vertically. And we do that by throwing these numbers into our equation. So if I change the a value, that's going to change the parent function. If I throw a value here with x, adding or subtracting it, that's going to change where that graph is. And then same thing with throwing a number at k, okay? So this is our parent function. So we're going to explore how all of these affect our graphs. Real quick, you're going to see this word a lot. I mentioned this yesterday in my video. It's an asymptote, and that is a line that a graph approaches as x or y increases in absolute value, okay? Is basically where this graph is going to go, and it's going to get closer to a line, but it's never going to cross that line. And so we know that our asymptote here, this graph right here is going to approach the y-axis, but it never actually touches the y-axis. And same thing here, it approaches that y-axis. So this is x equals 0, and that is an asymptote. And also it approaches the x-axis here, which is the equation y equals 0. So those are my two asymptotes for the parent function. Okay, let's look and see what we've got in terms of other functions. Here's one of the problems in your book where they want us to graph this. They want us to identify the x and the y axis. Okay, I hate it when it does that. Or they want us to identify the x and y intercepts and the asymptotes of the graph, and then domain and range. Okay, so let's go ahead and do this. We're going to go. We'll do this in blue. If I chose these numbers here on purpose because you'll see. When I plug in 1 in here, it's going to be -3 over 1, which is -3. If I plug in 3 there, that's going to give me -1. I'm going to go through these fast. If I plug in 6 there, it's going to be -1/2. Okay, let's go ahead and graph those very quickly. I've got a graph over here. Okay, if I plug in 1, I get -3. If I plug in -3, I get 1. My dog is barking. If I plug in 6, I get 0.5, right? And just to give me one more point, if I plug in 1/2, if I put 1/2 on the bottom, that's actually going to give me 6. So that's going to be right here, okay? And you can see what this graph does is it kind of goes like this, right? On the same note, we've got, I'm going to shut off my text messages here so you don't have to hear that. And we are going to, still going. Let's see, did I get that? Oh my gosh. There we go. All right. Let's go to, sorry about that. Here, we've got, if I plug in -1 here, I get +3. Plug in 3 here, I get +1. Sorry, plug in -3, I get +1. Plug in -6, I get +1/2. Okay, let's go ahead and graph those ones and see what it looks like. If I plug in -1, I get 3. -3, I get 1. -6, I get 1/2. And if I plugged in -1/2, that would give me 6 up here. That's just an extra point. And you'll see that the graph is going to look like this. Okay, so let's talk about our asymptotes first. Okay, our asymptotes, it's going to be a horizontal asymptote, okay, and a vertical asymptote. I said those backwards, but my horizontal asymptote, remember that's this line here, and that's going to be y equals something. And so y equals something. Where is it never going to cross? It's never going to cross the x-axis here. Okay, it approaches that x-axis, and that is the equation y equals 0. So there's my horizontal asymptote. My vertical asymptote, that's going to be x equals a number, and that is going to be 0 again because it never crosses that. Okay, my domain, all real numbers. Okay, for both my range and domain, except for what? My domain, or my x values, are never going to be what? X values are never going to equal 0. And my y values for my range, I can't have a y value of 0 either, okay? Because those are my asymptotes, okay? So let's move on. Oh, by the way, x and y intercepts, it doesn't cross the x and y axis. So there are no x and y intercepts. Okay, here's what we're going to do. We're going to now identify what happens when that a value changes. Okay, so we talked about how to graph it. Okay, now we're going to and asymptotes. Now we're going to talk about how the a value is going to change it. So what I'm going to do is I just graph these for you, and we can see right here the red one, okay, is going to be my parent function, and the blue one is what I did, how I changed the a value. So I put 1/2 or 0.5 as the a value, and you can see it shrunk it. Okay, if we change the a value to a +2, you can see that it grew it expanded, enlarged it, right? And if we change our a value, change our a value to a small a value, okay, means it's going to shrink it, but then we made it negative, and look what it did. It shrunk it, but then it reflected it, or it changed it from quadrant 1 and quadrant 3 to quadrant 2 and quadrant 4, right? So it flipped it, okay? Let's see. Look at this, write this in your notes. This is what it's talking about. We're really talking about the absolute value of a. If the absolute value of a is bigger than 1, then it's going to stretch that out. If the absolute value of a is less than 1, or in between 0 and 1, that's what's going to shrink it down, like the 0.5 that we just talked about. And if you see that the a value is negative, that's what this says, that's what we're going to reflect it across the x-axis. So it's going to flip it down and then flip it. That bottom one is going to flip it up, right? So the negative is going to change the quadrants, and the number big is going to stretch, small is going to shrink it down, okay? The h value here at the bottom, like always, the h value is going to change that horizontally, okay? Remember, if it's minus h, that's going to change it right. And if it's a positive h, that means we plugged in a negative h there, which moves it left, okay? And a positive k value is going to move it up and down, okay? Negative k value moves it down. And when we change it, when we slide this graph left to right, okay, and up and down, that's going to now change my asymptotes. So if I change it, okay, slide it left or right, that's a change in the h value. But what that does is it changes my horizontal asymptote over here. So that means my y value, okay, is going to change, okay? And the horizontal asymptote, when I change up or down, okay, that's going to change it. So I might have said that backwards, but I'll show you what this means, okay? It can get a little confusing because it is backwards, okay? So you can see this is what our combined is going to look like, and I will show you how this changes, okay? So what I did was I subtracted 4 on the bottom. That means I'm sliding it right 4. And as I slid this right 4, it went from my asymptote of x equals 0 to now my asymptote is going to be x equals 4, because it's never going to touch that right there, okay? So the h value, okay, down here changes my asymptote to be x equals 4. And my plus 2 moves it up. And so now my horizontal asymptote is y equals 2. Okay, you can see how that's going to now change that. Okay, so now we are going to do our last problem, which is going to be right here. You'll see this in your book. All they want us to do is they want us to sketch this, sketch the asymptotes, graph each of the functions, identify the domain and range. Okay, so they want us to sketch the asymptotes. So here's what. Okay, minus 2, which means I take these. Okay, the parent function, which is here and here. Okay, it looks like our little curve right here. Okay, in these two quadrants, and I move it down 2, right, which changes my y to be right here. So this down 2 is going to change my horizontal asymptote, okay, from y equals 0 to y equals -2, okay? And you can see that they didn't throw an h value in here, which means my vertical asymptote, or x equals something, is going to stay right there, okay? And my graph would now look something like this. Here and here. Okay, so my asymptotes, y is going to equal -2. That's this line right here. The y value is always -2, and x stayed as x equals 0. So what does that mean for my domain? Well, my domain and my range are still going to be all real numbers for both of them, with the exception, my domain, okay, or my x values, okay, cannot hit this line. So my x values, okay, cannot be 0, okay, because they can't hit this line. Now my y values, okay, my y values can be 0, because my y value here, right, that's going to be a y value of 0. My y values can't be what? -2. So y can't be -2, right? Make sure you put can't be those, okay? And I think that is it. Yep, that is it. We are out of here. Hopefully that helps. See ya.